I'm Bill Kramer, and I'm the Deputy Director of the Blue Waters Project at NCSA. Blue Waters will be the 20th supercomputer that I field, or am involved with fielding. Before I came here, I was involved with the National Energy Research Scientific Computing Center at Lawrence Berkeley National Laboratory that was funded by the Department of Energy. That experience there, I was the general manager of that facility for over 10 years, and we fielded a number of the world's largest machines for open science. Before that, I was involved with NASA doing a similar set of work, fielding machines for open science with the Numerical Aerodynamic Simulation Program. I came to NCSA because this is the most exciting and challenging project in high-performance computing in the world, at least that's the way I view it. It's trying to do something unprecedented, which is to field a system that has performance goals that are only driven by what scientists can get out of the system. Blue Waters is focused solely on sustained performance, the performance that really impacts the ability to make progress in science and engineering. And that is why it's such an exciting project. We are challenged to make sure the system works well for this diverse set of science ranging from nanotechnology all the way up through astrophysics, climate change, chemistry, materials, any type of science you can envision. The Blue Waters system has many more than 200,000 processors. It will have unprecedented capability. So to use that capability to solve the most challenging problems in the nation, the applications also have to be adjusted to make sure that they're able to make full use of the abilities of the system. Hence, working early with the science community to help them start to plan and then design and develop their applications, and as they change, is a very key important concept of Blue Waters. What that enables is that when the science community begins to have access to the machine, they're fully ready to go. So we're currently working with teams of scientists, we call them PACs, who are developing the codes, and those teams will expand over the next couple of years as the National Science Foundation allocates time on this system. We'll engage with more and more teams to help them get ready to run at this level, both to get the maximum amount of performance, but also the maximum amount of science or engineering out of the system. The science community can become involved with Blue Waters in a number of different ways. The first way is if you have applications that need sustained petascale computing. The National Science Foundation has a series of competitions for allocations of time on Blue Waters. They're making now initial allocations of time to on the order of 20 projects. And each year they will allocate more time to projects that need the computational power and the data-intensive computing power of Blue Waters, and also have the abilities to make use of the system in an effective manner. Another way to be engaged with us is that there's a series of workshops and educational forums that we're holding about petascale computing in general, and some activities directly related to Blue Waters. When we go into the operational mode in 2011 with Blue Waters, after we've gone through the early science period, we will be providing complete and full service support for the science community. We envision experts working with the scientists to make sure that their codes operate properly and at high efficiency. We also have an operations staff that will make sure the system operates well and is actually expanding as we go through this time period, so that the full impact of Blue Waters is not on day one when it is put into service, but is actually through a very efficient life cycle of many years of Blue Waters providing resources to the science community. And we look forward to that period as well as the period of introducing Blue Waters to the community.
The University of Illinois' National Center for Supercomputing Applications provides powerful computers and expert support that help thousands of scientists and engineers across the country better understand our world. With the computing power available at NCSA, researchers create computer simulations with real-world social and business impact. NCSA is supported by the State of Illinois, the University of Illinois, the National Science Foundation, and other federal agencies.